In this problem, we have a point P in the Cartesian plane. Cartesian just means your classic XY. And we want to figure out what it would be in polar form. So we're just going to imagine what the coordinates would be of this exact same point if instead of rectangles, these were circles, and this was the circular graph that we're used to seeing. So we would need to know what radius is this point on and what angle is it at. But first, to figure out what radius it's on, the radius is the distance to the origin. Let's make this a triangle. Because this point is at 6, 6, negative 6, this length is 6 and that length is 6. So we can do Pythagorean theorem to figure out the length. I get that c equals the square root of 72. Well, that's not any of my choices, but I know that the square root of 72 is not 6, so the radius can't be 6. A is out. 72 is just 36 times 2, and I do know the square root of 36. It's 6. So the radius is 6 radical 2. So that means D is also out. So now we have to choose between B and C, and we're going to choose by looking at the angles. B says an angle of negative pi over 4. C says an angle of pi over 4. We should be able to tell this just by looking at the graph. Positive pi over 4, you start here at the polar axis, and you would go a quarter of the way through one quadrant. That's pi over 4. And we can see that the point is not there. The point is in quadrant 4, which is negative 1/4 pi around the circle. So the correct answer will be B. If you're not sure how to see that, you can always use your calculator. But to find this angle here, your calculator will find the angle coming off of the x-axis. So in your calculator, you can say inverse tangent of the opposite, which is 6, over the adjacent, which is negative 6. And if you're in degree mode, in your calculator, when you calculate this, you will get negative 45 degrees, which converts to negative pi over 4 radians.